So in our discussion today, we are looking at the atomic structure and the periodic table. So we are going to start by looking at the atomic structure. So what exactly is an atom? Well, you can think of all the things that surround you. They are simply made up of atoms, and therefore when we define an atom, we can simply say that an atom is the smallest particle of matter that, if you want, you can continue and say that cannot be broken down further by chemical means. That is what we can say an atom is. Or alternatively, some books may actually define an atom and simply say that an atom is the smallest particle. They can say it is the smallest particle of an element. Of course, as the smallest particle of an element, it can actually take part in a chemical reaction, and that is what we simply call as being an atom. Now, you can think of an atom as a full stop at the end of our sentence that we do have. Now, way back, the people thought that an atom was the smallest particle, but as research came in, scientists came to discover that inside of an atom there are other smaller particles that are there, and therefore they called these smaller particles inside of the atom as being subatomic particles. So there are 3 subatomic particles that are found in an atom. So in simple terms, we can simply say, when it comes to an atom, this atom is made up of 3 subatomic particles, and these are namely what we are calling as being the neutron. I'll represent it by N for the sake of my discussion. We can also talk about the proton. I'll represent it in this case by small letter p, and the electrons, and these are going to be represented by E. So these are the subatomic particles that are found in an atom. Now, when we look at both the neutrons and the protons, these both neutrons and protons are found in what we call as being the nucleus, while the electrons are located in what we are calling as being a cloud space. So they are located in what we can simply call as being an electron cloud of particles, and therefore that electron cloud of particles is what we call as being in a shell. Sometimes it is called as being an energy level, because the energies are going to be different. So these are the subatomic particles that you need to remember. Now, when we talk about these 3 particles there, the neutrons, let me just talk about them further. The neutrons, N, the protons, P, and the electrons, in this case I'm using E. You're going to find that the neutrons have got, in terms of charge, you're going to find that the neutrons are actually neutral. They have got no charge. The protons have got a positive charge, and the magnitude of that positive charge is a +1. The electrons, on the other hand, have got a negative charge, so the magnitude of that charge is simply a -1. Now I can summarize the properties of the 3 subatomic particles. So let me say properties, or if you want, you can simply say characteristics. So properties of the 3 subatomic particles. So what are the properties that you need to remember for the 3 subatomic particles? I can put it up in a triangle, in a box, where I can simply say, in a table where I can say the particle. Then this side I can simply say the charge that the particle is going to have. Then I can simply talk about the relative mass, or the atomic mass unit, and I can simply talk about the location. Where are they located? So the location of the particle. So in this case, my first particle that I can talk about is the neutron. Then I can go to the proton. Then I can talk about the electron. So this is a table. Sometimes in the exam, you are going to find this table and they will tell you to fill it up in this case. So when it comes to the particle, the neutron, the overall charge of the neutron, like I said, it is actually neutral. In other words, it has got no charge. Some books, they write up a 0 there. Protons, in this case, have got a positive. So they do have a positive charge, but the magnitude is simply a positive 1. Electrons have got a negative charge, and this magnitude or the size of that charge is a negative 1. Now, what are the relative mass? What are the relative masses for these subatomic particles? What are the relative mass for these ones? Well, when it comes to what we are calling as being the neutron have got a relative mass of 1, and of course the protons have also a relative mass of 1, and the electrons have got a relative mass of 1 over 1840. Now if you look at 1 divided by 1840, that is actually negligible. It is the same as an electron has got a mass of 0. And of course, in terms of location, remember both the neutrons and the protons are located in what we call as being the shells, even that one shells, or you can call them as being energy, the energy levels. But of course, as you advance, you are going to understand about these energy levels and what we simply call as being orbitals. Electrons, on the other hand, are located, I meant to say that when it comes to the electrons are the ones that are located in shells or energy levels. But of course, for the protons and the neutrons, we did say that these are found in the nucleus. So that is what you need to remember. So both the neutrons and the protons are located in the nucleus, and electrons are located in the shells, which we sometimes call as being the energy levels. So if I was to look at the structure, of an atom, this is the way it is going to look like. So right in the center, I'm going to have those particles that are positively charged and those particles that have got no charge. So now these ones there are what we are calling as being the protons, and those that have got no charge are what we call as being the neutrons, and together they make up, or they form up, what we are calling as being the nucleus. Then surrounding the nucleus, the whole of this, I'm assuming it's actually the nucleus, then surrounding the nucleus are what we call as being shells, where those particles that are negatively charged are going to be orbiting at a very fast speed, and this is what we called as being the electrons, and that is representing the shell. So this is what you need to remember when it comes to an atom. Now there are some terminologies that are simply associated with what we are calling as being an atom. So let me show you a bit of some terminologies that you need to remember that we are going to be using that is associated with an atom. So some of the terminologies that you need to become familiar with. Number one, we can talk about what we call as being the nucleon number. Sometimes the nucleon number is also called the mass number, and usually this one is represented by a capital letter M. Now what is the nucleon number or the mass number? Well, the nucleon or the mass number is the total sum of protons. So the total sum of protons and neutrons. So the total sum of protons and neutrons in an atom. So when you put up the number of protons and the number of neutrons in an atom, that creates or forms up what we call the nucleon number. What do I mean? Well, I mean, in order for you to get the nucleon number, it is equal to the number of protons that are available in the nucleus plus the number of neutrons that are there in the nucleus, and they make up what we call as being the nucleon number. Remember, nucleon number is represented by capital letter A. The other terminology that you need to remember is what we call as being proton number. Now, the proton number sometimes is called the atomic number. So let me just put up that so that, and normally that is represented by Z there. So what exactly is the proton number? Well, proton number is the total number of protons, just the total number of protons in the nucleus of an atom. So when we just consider the number of protons that are found in the nucleus of an atom, that is what we call as being the proton or the atomic number. So that is what you need to remember when it comes to such discussions. And therefore, we can try to summarize from what we have looked at there. We are saying that in order for you to get the nucleon number, which is represented by capital letter A, it is equal to the number of protons, which is also represented by Z, plus in this case the number of neutrons, which I'm going to represent by capital letter N. So I can say the nucleon number is equal to the proton number plus the number of neutrons. Now it is possible, if you know the nucleon number and the proton number, it is possible for you to know the number of neutrons that are there. You just make N the subject of the formula by taking this Z to the other side. So meaning that N will be equal to, remember when Z goes the other side, it will be minus, so it will be A minus Z. In other words, if you want to get the number of neutrons in the nucleus of an atom, you just need to get the nucleon number and what we are calling as being, the proton or the atomic number. That is what you need to remember. I'll come that, to that discussion in a short while. But let me simply talk about, what we call as being the nuclide notation, so that you are able to see the nuclide notation. So we can talk about the nuclide notation, then we can do a bit, so nuclide notation, then we can do a bit of some gymnastics. So nuclide notation, well, the nuclide notation is simply a notation that shows, the symbol of an element, which we simply call as being the atomic symbol. The atomic symbol, then it also shows, remember, our A there is representing the nucleon number, and the nucleon number is sometimes known as the mass number. Sometimes you are going to find when you go on the periodic table, they'll call it the relative atomic mass, which is abbreviated as just the mass number. Then the number that is at the bottom there, the smaller number, this is what we call as being the proton, and sometimes the proton, like I said, is called the atomic number. So please do not confuse the relative atomic mass and the proton or the atomic number. Those are two different things. So you need to remember that. E.g., a very good, if you go to the periodic table, an element called sodium. So an element called sodium on the periodic table, capital letter N and small letter A, you need to know how to write the correct symbol of the element on the periodic table. So a sodium represented by Na is actually has got 11 and 23 there. Now what does that tell us in this case? Well, the number at the bottom is representing the number of protons. Remember, I'll put it as a P. The number of protons is equal to 11, and the number on top is representing the nucleon number, which is 23. And remember what we said, in order for you to get the number of neutrons, you simply get the proton number, the number on top, minus the number at the bottom there. And what is that going to give you? Well, that is going to give you a 12. So meaning there are 12 neutrons and there are 12 protons in the nucleus of the sodium atom, and that is what you need to remember. But I want you to understand in this case that when you write the nucleide notation, the smallest number will always represent the proton, will always represent the proton number. But for one thing is that when we talk about atoms, let me say that atoms are electrically neutral. What do I mean when I say they are electrically neutral? Or if I want, I can say, they have got no overall, let me say that they have no overall, charge. Why do atoms not have an overall charge? Maybe being positive or negative. If it's an atom, it is electrically neutral. Well, this is because the number of protons is equal to the number of electrons in an atom. Remember, protons have got a positive charge and electrons have got a negative charge. So because the number of protons is equal to the number of electrons, it simply means that there's no overall charge. It's like me telling you negative 10 plus 10. What will that give you? To give you a 0. So because the number of those that are positive and the number of the negative charges are the same, no wonder you are going to find that an atom is electrically neutral. This is a very important point that you need to remember. So therefore, let's go back again on the sodium atom that I gave you. Let's go back on the sodium atom. Sodium is 11 and 23. Suppose I told you to say, find the number of, protons, find the number of protons P, electrons, E, and neutrons in the N in this atom of sodium. Of course, a P, the number of protons, you just take that one this way, it's 11, and the number of electrons, because this is an atom, it is neither positive nor negative, it has no charges, it simply means the number of protons will be equal to the number of electrons. Then for you to get the number of neutrons, you just get your mass number, you subtract the proton number there, which is going to give you a 12. I hope you are getting the concept of what I'm saying. Let's look at just basically some few other examples so that I can actually get to show you. For example, I can tell you that find the protons, electrons, and neutrons in each of the following atoms. A, let me say you have got, this is lithium. If you go to the periodic table, then I can simply say in oxygen 8 and 16. Then C, I can talk about aluminium, which is 13 and 27. All right. Okay, so now they want us to identify protons, electrons, and neutrons in each of the following. Well, it is very simple how you need to go about it. For example, if I take lithium, remember 3 is the proton number, 7 is the nucleon number, also called the mass number. So protons will be 3. How many electrons? Yes, you are right. That is also going to be 3. How many neutrons? You get the bigger number minus the smaller number, which will give you a 4 then. B, oxygen atom. If I look at oxygen atom, how many protons are there? Well, if you look at the number of protons, it is simply 8. Because this is neutral, it means the number of electrons will be 8. How do I get the number of neutrons? It will be 16 minus 8, which will give me 8. So you don't need to to start struggling when they tell you to find the pen, or abbreviate it as pen, big proton, electrons, and what? Neutrons. Then C, aluminium. For aluminium, 13 and 27. How many protons are there? 13. How many electrons are you able to identify? You are right, it should be 13. How do I get the number of neutrons? You simply get 27 minus 13, and that is going to give you 14. So this is the way you can actually get to do it. Please watch out for more videos as I try to guide you, through the atomic structure, where I'm going to look at now the electronic arrangement or configuration. Thank you so much for watching. If you enjoy what I teach, please you can simply subscribe to my channel and give me that like button in there as you watch the videos. Thank you so much.